everyone. I guess it's time to start. My name is Balázs Bucsai, and I'm going to present you this chroot breaking Unix's chroot solutions presentation. Before doing that, let's just have a few words about me. I'm a Hungarian hacker. I have some strictly technical certifications like OSCE. Oh, okay. Sorry. So, for example, OSCE, OSCP. I'm currently working for a large telecommunication company, and my boss told me not to mention its name. But anyways, you can find it easily. I started with Ringo debuggers and disassemblers when I was really young in 2000, and I had one major project just after that in 2009. It was called GI John. Can I ask how many of you know this project, GI John? Raise your hands, please, if you know. Okay, 3 of you, and one of them is the writer of John the Ripper. So I guess it's not the best. That's why I stopped. You can find my webpage on the slides. It's rycon.hu and my Twitter account. If you like my presentation, please just follow me. And there is my LinkedIn profile as well. A brief history on chroot. It was introduced in version 7 Unix in 1979. 3 years later, it was implemented in BSD. And the hardened version of the chroot was implemented in 2000 in FreeBSD. It is called jail. In the same time, the Virtuoso guys, now it's called OpenVZ, started to use, they implemented the containers, what we call containers nowadays. It is a live project as well. 5 years later, the Solaris created something called chroot on steroids. This is basically the Solaris containers. These are the Solaris containers. And in 2008, the Linux containers were implemented. And this is the part of the Linux kernel now. So you can create Linux containers easily, because most of the namespace stuff and those kind of stuff are in the kernel. But what is chroot? This is a privileged system call. Only root user can call it, or somebody who has chroot capability. Every process on the Unix systems have a process structure, and in that process structure there is an entry that is called root entry, and that stores the vnode of the dedicated root directory. So that's how it knows that's the root directory of that process. If you call the chroot in that process, then you can change this entry. You can change this vnode entry in that process structure. So the process won't be able to escape that directory anymore. So it won't be able to see the outside of that directory. Why we need this system call to be privileged? The reason is that if let's see an example. If you are a simple user and you can use the chroot environment, then you can craft a directory structure. For example, and you can create an etc directory, and in the etc directory you can create a sudoers file, and in the sudoers file you can just put some lines that your user is able to use the sudoers, so your user is able to get root privilege on the system. So if you could do this with a simple user, then you could get privilege escalation in a minute on every Unix system. So that's why it's privileged, and that's why it can be only called by root. Some operating systems are not just storing this entry in the process structure. It is they are, for example, FreeBSD. Linux is only storing one entry, this vnode, but for example, the FreeBSD is storing a linked list with all of the previous roots and the current root as well. I'm going to explain that in a bit. So what is the chroot used for mostly? It is used for testing environments, dependency control, compatibility, recovery. Sorry. Yeah, so for example, if you broke your Linux system, then you cannot boot it. And if you just get a live CD and boot on the live CD, then later you can mount the original root partition, and you can just use the chroot system call on that partition, on the root partition. So you will be able to access all the files on your system, but you will be using a different kernel, the live CD kernel behind it. Or if you have different applications that are using the same shared libraries but different version, and there is the compatibility error, then you can create multiple environments, chroot environments, and use those to be able to run both of the applications in the same time, but using different shared libraries but using the same name. And it is used for privilege separation, which is sometimes not the best idea to use for. But before we are going forward, I have to ask, what do you think? Is the chroot a security feature or not? If you think it's not a security feature, then please raise your hands. Yeah, that's the question.
Yes, but it is used as such.
Yeah, that's right. So this is the answer. No, it's not a security feature, so please don't use it like that one. You can use it for many purposes, but to be sure, not sure, but these are the requirements for a reasonable chroot. I could write secure chroot as well, but since this is not a security feature, I wouldn't use that word anymore. So to make sure the user in the chroot has a really hard time to get out, you should just follow these rules, thumb rules. For example, all directories has to be owned by root. No super user process should be run in the chroot environment. By the way, you should use distinct and unique user IDs and GIDs in the environment. So if the user manage somehow to break out, then he or she won't be able to access any files or modify any files on the original system. And basically all of the points here are the same. The user shouldn't be able to create sensitive directories and files, for example, user or lib directory, because then they would be able, the attacker would be able, the user would be able to put some shared libraries in those directory. And if you have set UID or set GID binaries in the chroot, they would be able to load those malicious shared libraries, so it wouldn't be good for you, because they could get privilege escalation there. A few more requirements for reasonable chroot. When you call the chroot system call, before that, in your application, you should close all the file descriptors, because those file descriptors could be used to escape your chroot environment. And what is not really important here, that Unix operating systems are not changing the current working directory before chrooting or after chrooting a directory. So you should use chdir system call before or after the chroot system call as well. And if you are creating a chroot environment, please don't mount the procfs into any directory, because it is really easy to get out if you have the procfs mounted in the chroot environment. And in that case, you don't need files or directories in your siege root. Just use the var empty directory because that's the purpose of that directory. Sorry. There are two distinct scenarios where you can get access to a siege root environment. The first, when you have shell access to it. For example, you have a SSH account, and you can just SSH in it in a siege rooted environment, so you can execute commands, run binaries. The same scenario when you have a siege rooted Apache running with different modules, for example, mod CGI or mod PHP, and you somehow manage to run code in PHP, so you can access different commands on the server in the siege rooted environment, or you just found a vulnerable siege rooted application and you have a vulnerability in that, and you run an exploit against it, and you got a siege rooted shell. The other scenario, where you have SCP or FTP access to a siege rooted environment, but you cannot run any kind of commands or binaries in that because you only have FTP or SCP access. This presentation mostly will about the shell access part, but I'm going to show you some tricks for the file system access only as well. And most of the techniques are basically the same. This is the overview how these are working. First of all, you need to get root. Not all of the techniques are needing it, but most of it. If you have root, then you need to get somehow a file descriptor outside of the siege root. With that, you can access the original file system, and just changing the directory back to the parent, so just cd ... you can access the original root and siege root into that, so you will get the original root basically, and you are escaped. But it's a really highly summarized what I just explained. Like I told you before, the Linux is only stores the vnode in an entry of the process structure in the process structure. But for example, the FreeBSD stores a linked list. So if you break out from one siege root to another, you won't be able to access the original root. But I'm going to show you that. Is it working? So we have the original root here. Under the original root in the home directory, you can find the siege root environment here. If you call the siege root system call on this directory, then your process won't be able to access anything above the siege root directory. That's the main point of siege rooting. But you can do such a thing like siege rooting in that environment, or you have already access to that environment, and you are creating a secondary siege root inside that siege root environment. And if you manage to break out from this siege rooted environment on Linux, then you can access everything because you are above of the dedicated root of that siege root environment, for example here. But on FreeBSD, if you break out from this environment, you can only access this one because it stores the root entries in a linked list. So your process will be stopped here and not only here. So that's the main difference between the operating systems. Okay, I stay here because I have to show you other things. So the most trivial thing what you can do, of course, it's trivial in theory and not in practice, to just use a kernel exploit because you don't need to have a user account for that, a root account for that, because that's the point of the kernel exploits, basically. Or if you have root, then you can insert a kernel module, and both ways you have access to the kernel space, so you can modify the process structure. You can just override the process dedicated root entry, so you are outside of the siege root. But I'm not going to talk about this in depth because it's another topic. The second thing here, what is really trivial in theory again, but it's hard to recognize if you have a siege root environment, that if it wasn't done as a reasonable siege root, like I told you before, then it's sometimes it's easy to break out. Let's see an example. If you have the etc directory writable for the user, then it is then the user can delete the passvd and the shadow file and replace it with its own, and that way he will be or she will be able to get root and again get access to the kernel space. Or if we have hard linked set UID or set GID binaries, then we can just replace the shared libraries under it. It will load it, and we can get command execution, code execution by these set UID and set GID binaries. And this is where the stuff starts, really. This is the oldest technique that is known. If you look for the siege root escape techniques, you will find this one. It's really trivial. It's really elegant. You just create a directory, siege root into that, change the directory back, and siege root into that. But I'm going to show you here. So the scenario here, you have access to this environment here, and your process isn't able to access anything above, right? That's the main part of the siege root. If you go to the current working directory will be the home directory. So if you write just cd home, that's making your current working directory to the home. And if you call the siege root system call on the users tree directory, it won't change your current working directory again. Like I told you this before, that Unix system doesn't change the current working directory. That's why your new siege root will be this one, but you are still outside of the siege root environment, so you will be able to access everything. I hope that's clear. So you are just creating a secondary siege root into that directory, but still you are out of that because it doesn't change the current working directory. So you will be able to access everything on the system. But like I said, on FreeBSD it's not working properly. You can only break out from this directory from this directory because it's using a linked list. So this is the original root, this is the first siege root, and this is the second siege root. So if you break out from this one, you just get back to this one because it's a linked list and it's checking backwards the roots, and it will stop the user here, the process. Okay, this technique, the second technique, the classic technique with the file descriptor saving, it's based on the first one. But for example, GR security, that famous patch is changing the current working directory. So if you siege rooting into that directory, it will just call the siege dir directory on this one. So you won't be outside anymore. So you won't be able to break out. And this technique is not working on GR security, so don't misunderstand me. It was just an example. But before, if you are siege rooting that directory, and before of that you are saving the file descriptor of that directory, then after you can use this file descriptor of the home, for example. You are saving the file descriptor of this. You will be able to use this file descriptor because it's in the memory, so you can access it, and just change the directory to that with the fchdir command. It's pretty easy. And that way you will be outside of the siege root again, so you will be able to access everything above. The third technique, it's really interesting. It's about Unix domain sockets. These are really familiar with the internet sockets related to them, but here no network device is involved. So you don't have to have an Ethernet card or anything else or an IP address because it's done by the kernel only. So it's like a normal socket. You can create a socket, and from the other side you can open that socket and you can pass through data in both directions. And the best thing about this, you can pass different kind of structures as well. So And one more thing before I'm showing you how it is done. There is there is one thing. Well, there is one thing. It is called abstract Unix domain socket. It is supported by the Linux only, as I found out, and that way you can create these kind of Unix domain sockets without accessing the file system. So you don't have to put a socket file on the file system, and there is no permissions involved. So with the abstract UDSs, you can just create a socket and open it from any process without permission denied or any other problem. So what we are going to do with this technique is we have the original environment here. We have the chroot environment where our user is logged in, and we want to break out, right? So we are just executing a command, a binary, that will do just a fork. So it will just fork. It is going to have two separate processes, right? The first process just wait in the chroot environment, and the second process will just will chroot into the second chroot environment. And one of the processes will create this Unix domain socket. The other one just connect to it, and that way the outside chroot environment will be able, for example, to pass over the file descriptor of the home to the inside chroot, and that way, by opening from the chroot2 environment the home file descriptor, that process that is logged in the chroot2 environment will be able to access this directory, and because of this, because of that home directory is outside of the chroot2 directory, as you can see it here, it will be able to access everything. The fourth technique is the mount. So you just look for the root partition, the root device of the operating system. You mount it in a directory, and because if that's the root, you can chroot into that. So it's really easy to do that. But you have to be careful because it's a really strange thing that Linux is not restrictive on it. So you can mount the root partition or any partition that is already mounted on the computer, on the operating system. So it could corrupt your file system. So it's not the best idea. So I have to modify my tool to mount it only read only, because it probably won't mess up your file system. Okay, the fifth technique is mounting the procfs into a directory. If you have the procfs mounted, then that directory will store all of the processes that you have on the system by the PID. For example, the PID, the first, is connected to the init process. And if you just go to the proc1 root, then you can access the original root. So if you manage to mount the procfs to a directory and you just go to that directory, then you are outside of the chroot. And this is a really interesting technique for me. I found it 5 years ago, and I didn't do anything with it, but I realized maybe I should. That's why I am here. I started to work on this project with Solar Designer's help. Thank you for that. And we figured out that we can just, do a better, entertaining presentation about it, and that's why I am here. So this is a little bit tricky technique, but really easy to understand. Let me show you again. So we have the original environment inside the chroot environment, and like before, we are executing a process that is forking. There will be one process chrooted in that chroot environment. The other one is chrooted in the second environment. And in the second environment, we are changing the current working directory to the user3, for example. So the second chroot process, current working directory will be the users tree. And from this environment, we can access this directory, right? So what about if we move out, rename this directory, and just move it here? So it will be the home under the home directory, it will be the user4 directory in the future. That way, the process that has the current working directory in the users tree will have the current working directory in the user4. So it will be outside of the chroot. So it will be able to access the whole structure of the file system. That's the magic behind it. And the last technique what I'm going to present you today is the ptrace. It's really interesting. I really liked it because you have to do some shell code and debugging stuff here. It's another kind of system call, but it's not privileged. So any user can call it, not just root. And the reason why we have these in the Unix systems is that you can debug, observe other processes with this system call. You can get the registers of the process. You can set the registers of the process, or you can just modify data in the process space. Even you can change the original code and you run your shell code basically. Root can attach to any process, and the simple user can attach to only the same UID processes, but only in that case when the processes, if effective UID is the same as the UID. So you cannot do that on set UID binaries. And that's the time for the demo. So I have 4 boxes here. One is Kali Linux. The other one will be Ubuntu, but I'm going to show you later. And a FreeBSD one, no, an OpenBSD one, sorry, and a Dragonfly BSD. So I wrote this tool. It is called Chw00t. It has different kind of methods already implemented, and I have a Chw00t environment just here in the home Chw00t test env, and I have different kind of files. But if I use the chroot dot, I created my Chw00t environment. I put the ls binary inside of it, so I can list the files. And if I check the slash, as you can see, the root changed to this environment, so I cannot leave it, not by trying to list the parent of it, because that's the root. So the process will be stopped at that root. And I'm trying to get out of that, so I just call my tool. This is the Chw00t, and I try to use the classic technique. It's the 0 one, the O one. And I have to specify the technique and the directory for it. Let's call it A. And I just push enter, and as you can see, I'm outside of the directory. I already explained this trivial technique to escape that was the first technique what I explained. So I am outside. No, because I left the shell. I'm back to the Chw00t environment. So as you can see, I cannot leave it again. But if I just try this the other technique, for example, the Unix domain sockets, I had to specify the directory again. Let's try another one. It's forking. As you can see, it's doing a lot of stuff, sending the file descriptor to the Unix domain socket. And as you can see, I'm outside again. Okay, that was the first demo. The second demo will be shown about the OpenBSD. I'm going to cheat a little bit. So I'm logged in with root on this FreeBSD box. I go into the Chw00t environment that I created before. So you can see I don't have too much stuff here. And here I'm just, so right now I'm root, as you can see. And I have this tool that makes me UID 80. It doesn't really matter what's the UID, you know. What it matters that I'm not root anymore. And I'm going to call this process. It will run outside of the siege root. That's the main point with the UID 80. It is not doing anything. It's just printing out the PID of the process and sleeping for 1 second. So it's not doing anything. And yeah. On the other shell, I'm going to use the siege root command. And now I am logged in that siege root, so I cannot leave it. And if I use this siege root tool again, then I can present you the method 7. It is the ptrace for 64-bit binaries. I have to specify a port. It will be 4444 and the PID. So normal circumstances, you just look for a PID, you just brute force it or anything else, and try to attach to that process. But because of the demo, I started one in the back, but it won't work. First, I have to lower my UID as well. Sorry. So I'm UID 80 again. So it's the same UID, and I'm not using the root privilege. And I have to type or guess the PID here. Okay. Looks like it works. So what happened in the back? As you can see, it's stopped. So it's not doing anything. I attached to that process. I modified the code. I replaced the original code with my shell code. It is looking for an input, and that's page days 15. And now I can type anything. So there is a shell listening on the port 4444. As you can see, if I list the slash, the root, then I can access everything. This is the original root. So that was the demo for the OpenBSD. Okay, I logged off. Yeah. And let's try the Dragonfly BSD. I logged in. There is a siege root directory in the root. I use siege root here as well. And if I try to leave the directory, I'm not able to do that. But still, I have the siege root binary here. And if I use, for example, the move out of siege root technique, and I specify the directory, the nested directory, and the temp directory, then it is doing something, but it's not answering anymore. And if we go back and look for this one, as you can see, it resulted in kernel panic. So on Dragonfly BSD, it is not working properly. In really weird circumstances, you can break the whole operating system with even by a simple user. So you don't need to be root, but it's a really strange way to do it. Yeah. So it resulted in denial of service. Back to the presentation. Here are the results. Every technique is working on Linux. I mean Debian and Kali Linux. The Ubuntu is an exception. The ptrace is working with root privileges, but it's not really working with the simple users, because in Ubuntu there is a restriction that says you can only attach to a process if it's your child process. So that won't work in our case. On Dragonfly BSD, the classic, the domain sockets, Unix domain sockets, and the move out of siege root technique results in denial of service. On FreeBSD, because of the linked list that I explained to you several times, the Unix domain sockets and the move out of chroot technique is partially working. If you have some kind of help from the outside, from the real root, then you can break out, but it's not really a real scenario. And the ptrace is working properly, even with simple users. NetBSD is the best or the worst one. Decide on it. And it's not working. So any of the techniques isn't working on it. Maybe the new ones, what I'm trying to implement. And OpenBSD, that was the biggest surprise for me. Like I said, it's not a security feature, so we are not talking about security vulnerabilities, so it doesn't count really for OpenBSD, but still the move out of chroot and the ptrace is working, and the Unix domain sockets are working partially only, like in FreeBSD case. Yeah, and that's basically the case. The ptrace is only implemented in a strange way on Solaris and Mac OS X, so I couldn't test it. And yeah, the mount is only working on Linux. That is strange again. Then other table what we have here is the difference between the FreeBSD chroot and FreeBSD jail. The only difference is the ptrace. The ptrace is working on chroot, but it's not working in a jail because it's more restrictive. That's a good news, I guess. So I have this tool, and I'm willing to release it. So please raise your hands if you want to have it on the internet. Okay, that's really good, even better than I thought. Thank you. So after the session, when I have a little time, and I think I will in 1 hour, then I'm going to release it. But like I said, in the beginning of the presentation, I told you in the beginning of the presentation, there are two distinct scenarios. One is when you have the shell access, and the other one when you only have the file system access. For example, if you have FTP or chrooted SCP access, then I'm going to show you that the move out of chroot is still working on those circumstances, and it's a really good thing. And I don't really have time to talk about these, but these are really interesting issues. If you have a misconfigured FTP server on something similar, then in special cases you can upload malicious files, and you can create sensitive directories that will be used by the FTP server. For example, in a misconfigured FTP server, you can create the lib directory. You can put your shell libraries, malicious shell libraries, into that directory, and in really weird cases, it will load from the chroot environment. So basically, you can run your code on the FTP server on the fly when you are accessing the FTP server. But like I said, it's a really strange scenario, so it's not easy to have it. But I saw, and we saw different ways when it was done. For example, King Cope wrote an exploit. I think it was against the libc, and he managed to upload a malicious file into an FTP server, call a command on the FTP server, and that malicious file was parsed by the FTP server, and that way he managed to exploit that vulnerability. And one more thing, these slides, this slide is not really clear, so if you have any questions regarding this, just please come to me. With the Linux containers, you can create privileged containers. That way you give a lots of resources that container. Even you can create nested containers in that container. And if no user namespaces are involved, then you can create the nested container, and by using the move out of chroot technique, you can get out of the containers, and I'm going to present it now. So I'm going back to the Kali Linux, SSHing to the Ubuntu box. And I'm listing the Linux containers on the Linux, on the Ubuntu. There is one, it is running, it is called LXCO. If we go into var lib lxc, then I can show you there is the container. I just cd in, and there is the config. So if you have these two lines in the configuration, then you can mount C groups inside the container, and you can create nested containers as well, and that's really good for us because I'm attaching to the LXCO. Same here. So the scenario here is that you have this privileged container somewhere, and you are logged into that. But if you manage to create another other container, and I'm not going to show you how to create one, but it's pretty easy. But we don't have time to do that. But there is another one inside the container. It is called LXC1. Then I'm creating in the nested container other directory. I just cding into that directory, so the current working directory will be that test in the /1 in the root, and from the LXCO where we are logged in, we can access that directory if we go into the var lib lxc1, and there is the rootfs directory. As you can see, I can access everything in the nested container. That's a thing that should work like this. But if I move this test directory, that is the current working directory of the other process in that container, to the TMP of the LXCO, then I can access the real root of the host. So I broke out from the container, and I wasn't logged into the first container. I'm able to access everything on the host. So if I going out, still, as you can see, it is unreachable because it's using a different mount namespace, but still I can access the host file system. But this is only the case in privileged containers, and privileged containers are not recommended by the LXC. So it's a really strange case. I just wanted to show you that the move out of chroot technique could be working on different architectures and different operating systems and different ways. By the way, as far as I know, but I'm not sure about this, for example, the iOS is using chroot or something similar technique to lock the application into its directory. So maybe that could be used somehow. Back to the presentation again. I would like to implement a few new techniques. So if you have some techniques in mind, then please just come to me and tell me. I have to improve the code, so I'm willing to share with you, but I know it's a mess a little bit, and there is space for improvement. For example, the ptrace technique is killing the process, and that's not a good thing. Probably it can be done with threading. And it would be nice to test the tool on different operating systems as well, I mean Unixes. For example, AIX or HPUX. So if you have a box and I could use it, then it would be nice to have a look. And what's really important here, if you want to contribute, I'm open to it, so we can do it together. If you have new ideas or you just want to fix my code, then of course you can. So please come to me and we can talk about that. And the last slide, almost the last slide, so I would like to say thank you for my girlfriend and my family because of the support what I got from them. I don't really had too much time to deal with them, and had time for my girlfriend because I was doing this presentation and the tool. I would like to say thank you for Wolfie and Solar Designer, who is sitting here, for mentoring me, and Spender and Christoph Feist, who is my colleague, for reviewing the slides. these are the references. You can download it from my webpage. So it's right now it's not really important because you cannot read and type everything, but later you can find it probably on the PhD's website as well. And thank you for your attention. If you have any questions, that's the time. And just a second, you can find my webpage there, the GitHub repository as well. So you can find it easily if I upload it. And Twitter account, if you like my presentation, please follow. And I guess the first question.
Thank you for so really good topic.
Thank you.
My question is, do you have any sport interest to find some security faults similar to you have mentioned in free or NetBSD? Because you wanted to test AX, HTTX. It's interesting. I agree, but I think for fun and profit, we put that deep in Net and FreeBSD.
Okay. Yeah, that's right. So like I said, it's not a security feature. So it's for profit. I don't think it could work. Yeah.
No,
For fun, yeah, more certainly.
you found, but they must be.
Okay, and yeah, we just talked about with Solar Designer about this, that we should do some research on NetBSD because it's an interesting topic, like you said. So yeah. So really, didn't know that. Yeah, sure. I don't really use. Yeah. Okay. Any other questions, maybe? Oh, sorry. Do I have any progress on chroot breaking methods or? Yeah, ptrace. Oh, sorry, I didn't get the question. No, I have no access to any kind of other architecture. So maybe my mobile phone, but I it's not the best way to do. So no, if you have architectures that I could use, then I'm happy to do some shell coding and that kind of stuff. So yeah. And by the way, yeah, never mind. So I will work on that as well. I used virtual machines for all of the operating systems, so it's basically the same architecture because it's using x64 or x86. Yeah. So for the ptrace, the tool what I implemented is only working on Linux right now. Like I showed you, in some cases it's working on different operating system, for example OpenBSD, but I had to port it, so that code is more awful and I'm not willing to release that, so I have to port the original tool to different operating systems as well before releasing that feature. And right now it's only supporting the 32 and 64 bits Linuxes. I think the namespace is a really good idea to have, and we should use that, but it's not a security feature again. So these are just there. It's good for some kind of separation, but that's it. What do you mean vulnerable? So for example, like here, there was mount namespaces involved in the Linux containers, but because I had root, I managed to access, I managed to move directory from one to another, and that way I managed to access all of them. But there is another way, what I just got an email about. There is a guy, I think his name was Jan, I don't remember right now, I'm sorry about that. And he managed to made some cross-mounting between namespaces, mount namespaces, and he managed to read some strange way a different container from one another. So yeah.
So to have ptrace so supported for some operating system, Is it really so bad? As I know, it may be used to implement anti-debug feature.
Yeah, there is.
So, and from your point of view, is it
From
really?
my-
It's a really gap. Is it real gap?
I don't think so. If it would be a gap, it wouldn't be in the kernels. I really enjoy to use it, to be honest, and that's the main point for me. So
So what about Android? Android, does it support btrace?
I guess so. I have no experience with Androids, but it's based on Unix, so I guess so. But I'm not an expert in this question.
Thanks.
You're welcome. Thank you.
New recommendations about the reasonable chroot. Do they use PHP techniques?
Let's go back to them. If you keep most of those, then it's really tricky to break out. I don't really know how to break out them. So for example, if you keep the first point, you cannot move out any directories because you don't have the privilege. That's respectively with the third point as well and the second. So if you have distinct user IDs and then GIDs, then you cannot really do anything in the siege root, so that won't be a problem. Oh, and I'm sorry, do we have time? Because I forget to show you another demo for 4 minutes. Okay. This is okay, and I guess I cannot show you that was about some FTP stuff, but maybe after the presentation. I'm really sorry, I forgot to show you that. So thank you for your questions and the attention.